Okay, let's take a look at this confidence interval problem. Marine biologists study the biochemical properties of fast and slow muscles of crayfish. 12 different muscles are looked at from one sample, and then 12 different muscles are looked from a second sample. Find a 99% confidence interval for the protein uptake rates of the fast and slow muscles of crayfish. First off, we recognize that this is indeed a confidence interval problem. It concerns an average, the average uptake rate of the protein. This involves two samples. We have one sample of crayfish and then another sample of crayfish. We're looking for a 99% confidence interval as opposed to a bound, and so this is a two-sided problem. This one is a small sample because we have less than 40 in at least one of the samples. It is unpaired. We're not looking at the same 12 crayfish for this problem. And because it's a small sample, we will be using the t-distribution. Okay, so let's set this one up. We have a confidence interval problem, so the center of the confidence interval will be located at 0.57 minus 0.37 for 0.2. Okay, so that will be the center of the confidence interval, so 0.2 plus or minus something. The standard error is equal to the square root of 0.104 squared over 12 plus 0.035 squared over 12. And this works out to be 0.031677. To get the critical value, we want a 99% confidence interval. So I want 0.99 to be the area in the middle. That leaves 0.005 to be the area in one tail. So that means I need the 0.995 to be the area to the left. So once again, we can use the calculator to find the inv t, pardon me, 0.995 comma degrees of freedom, or we can find the area using the right tail down here. Now before doing that, of course, we need the number of degrees of freedom. So the degrees of freedom, we have the complicated formula, 0.104 squared over 12 plus 0.035 squared over 12, whole thing squared, all over 1 over 11, 0.104 squared over 12 squared, plus 1 over 12 minus 1, 0.035 squared, divided by 12, whole thing squared. And this works out to be 13.46, which we automatically round down to 13. So in our case, we have a t-distribution with 13 degrees of freedom. And so we've used the table to find the number so that 0.005 lies to the right, or else we use inv or t.inv on a calculator to find 0.995 to the left. And this number works out to be 3.0123. So we have 3.0123 times the size of the standard error, which is 0.031677. So 0.20 plus or minus 0.0954. That's probably too many decimal places for the accuracy of this problem, but we'll just let that go. So there is your 99% confidence interval for the difference in the uptake rates.